Hey everybody, what's going on? Today we're going to go with some resistance math on speakers. Another one of the common questions that I always get is if we have a bunch of speakers set up and we're trying to figure out, well, what's the ohm load that my amp can take? Well, the simple explanation is, let's say this is 4 ohm, 4 ohm, 4 ohm, and 4 ohm. And there's only 2 wires coming out of it. And let's say we join this one's positive to this one's negative, this one's positive to this one's negative, and this one's positive to this one's negative. And then we come out and we go to the amp. What you have for the ohm load here is the sum of all the resistances. So you have your negative line here and your positive line here. So the total resistance for these is going to be the sum of them. So this is a 16 ohm circuit. Now some of you are saying, okay, well, that's really simple, and we already know that. Now, if we have a speaker and it's 4 ohms, another speaker that's 4 ohms, and we hook them up like this, what is the resistance? Well, most will tell you that the easiest way to figure out what the resistance is you take the two that you're putting together, which are both 4s, and then you divide them by 2. So as you add another speaker, you end up half. So now you have 4 ohms here, but here you have 2 ohms. So everything coming out is 2 ohms. If you have a dual, a sub, that has 4 wires coming out, and this sub is a 2 and a 2, that makes this 1 ohm when you connect these two together and these two together. Now if your sub has a positive and negative, a positive and a negative, and you jumper these two and come out, and this is a 2 and a 2, what you're going to get is 4 ohm. Alright, so now that we've gone over the extreme basics and we figured that out, what most shops won't tell you is if I have 3 subwoofers in a line, and let's say they're single voice coil, meaning only one positive, one negative coming off each one, the ohm load on this one, they're just going to figure it doesn't work because it's not an even number, or the amateur won't think there's an even number. But if I put 4 here, 4 here, and 4 here, what do I get? Because if I go half, half, and half, I'm not going to get 1. Or am I? Well, let's find out. Let's actually do this the way that I'm used to doing it. We'll just do it the more technical way. So instead of using something like this, where it's always a standard of 8, 2s, things like that, let's do things a little more scientific. What if it's 7, 11, and 1? And that's the ohm load of the sub. Then what happens? Well, most people are going to say, well, they don't make them, so who cares, but let's take a look, shall we? What we're going to do in this system is we're going to establish how you figure out in parallel what all these would be. Because if all of these were just, one was tied into the other and then they all came out to 2 lines and they're in series, the answer would be, what do you think? 19. It'd be 19 ohms because 7, 18, 19. In series you add everything together. These are in parallel. Positive, 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 negative, 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 and negative. So these, the way this works, is going to be resistance total equals 1 over the first resistor, 7, plus 1 over the second resistor, 11, plus 1 over the third resistor, 1. So, let's do the math. 1 over 7 equals 0.1, oop, wrote that wrong. That equals 0.143, and we're rounding to the nearest 3, plus 1 over 11. And that is going to be 0.091 plus 1 over 1 is easy, that's 1. Now we add them together. This system totals out to R total equals 1.234 ohms. That is what we have here. And that is how you figure it out. Now mind you, this equation, when you're doing it in parallel, can be anything. It could be the first one, the second one, the third one, and this can keep going and going and going all the way down until you run out of space or out of equipment. So instead of trying to figure out what everything's going to be by guessing or just halving everything, actually no, because if you get into some of this stuff, not all of them are going to be even numbers. Now, what exactly do ohms actually mean? Because, you know, you get these things that you got 1 ohm stable and half ohm stable and competition levels, things like that. Well, let's try some dead reckoning on this. Let's try and do all 4 ohm, and we'll put one more in there, and we'll get rid of this. A seasoned audio guy will know that this is 4, 4, 4, and 4. This is 1 ohm. Let's try it. Let's see if the math actually works. R total equals 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. Quarter, half, 3/4, 1. We know it equals 1. Perfect. So now, let's go back like we did with the relays. Alright, so now we're at the point where we come down to what is inside the amp. What's actually happening here? So we have a speaker, and it's out here making noise. We have a push and we have a pull. How does it do that? Well, there's a thing in there called a field effect transistor, more commonly known on the market as a MOSFET. And what that is looking like is just one of those little switches. It kind of looks like this with 3 legs on it. Alright? And when your amp is a square, and you notice that the heat sinks are all on the edges on the outside, power comes in, signal, a couple speaker lines, things like that. What's going on is you are having a negative and a positive signal, and you have MOSFETs that are on the outer edges. And what those do is they switch on and off really, really fast, and it's just like a relay like in the last video. And you have a sound card. What that sound card is doing is it's taking the signal from the radio, it's putting it in here, and it's using it as a pulse width modulation system. We have a positive, we have a negative on the speaker. Technically not, because this is just an identifier so you get the polarity the same. That does not mean there is a positive and a negative polarity sensitive part of the speaker. It doesn't matter if it pushes out or in. What does matter is sound pressure level, which means that all the speakers need to push out at the same time, or all of them need to pull in at the same time. They're allowed to do either one, but they all have to be the same. So the color coding to the speaker poles doesn't really matter as long as they're all consistent. So how does the amp work? Well, it puts it into this little sound card, and this sound card comes out to these MOSFETs and it goes to what is called a base. The base is what triggers these on and off. Normally, these are normally open, meaning there's no connection in here. Like in a relay, when it's sitting dead on the table, it's off when you connect the top and bottom pin, like in the last video. So you have a base, you have a collector, and you have an emitter. The base is the trigger. The collector is the part that hooks directly to your battery power that's sucking down all the juice from that main 4-gauge or 1-gauge cable. And the emitter is what's putting an output out there. It's connecting the battery to the speaker. Because it's pulse width modulation, you'll find that the power can be managed up and down. It's not just straight 12 volts. Or in some cases, on some amps, you can go all the way up to 100 volts. Well, how does this thing push and pull? Well, what will happen is you'll have a sine wave coming out of it. The emitter will go to the speaker on both sides, and the collector will go up here to the positive. Okay, so what the hell is a negative for? Two things. One, so the amplifier can operate. Everything in here at some point needs a ground, including the chassis and the sound card to run. And two, the base on a transistor is hooked to both positive and negative. And then what you do is you trigger one or the other polarity to turn it on or off. Some of these turn on when they're on ground, or they turn on when they're on positive, or they turn off when they're on positive, or turn on when they're on ground. So these right here, because they are turning on with positive, in this case, if you're interested in that kind of stuff, this is kind of off topic. If these turn on with positive and they're normally off, this is an NPN transistor. NPN. Easy way to remember what triggers them to turn on or off is look at the center letter. If it's NPN, it needs positive. If it's PNP, it needs negative. But that's beside the point. We're getting a little too far into electronics. So what ends up happening is the sound card will trigger this one. It'll put out an output of positive, and it will force the speaker out. Now, as this one, the pulse width modulation starts to shrink, what will happen is less power is getting to the sub, and it starts to come back in. And what's happening is this starts to go down. This one will start to come up in power, which is forcing it this way. When it passes that zero line, it's because this one and this one are now being overpowered by each other. So this one is now powering it more toward the negative side. This one's powering it more toward the positive side, or excursion side versus retracting side. And that's how your amp works. This whole rail up here, if this is 100 amp, and let's say you got a 500 amp set of MOSFETs in you, you'll probably have 5 of these, all with jumpers going to each one of the gates, and they all are pushing the same amount and pulling the same amount. That's how your amp works. These two things here are where the heat comes from. These can only take so many amps, and they don't have a lot of protection on them other than thermal. So if it doesn't get a chance to get hot, like you run at 1/4 ohm, and this is a 1 ohm stable amp, you'll blow these up before the thermal resistor can actually trigger and shut it down. And that is why you run into problems with overheating, is because these are being driven too hard. If it's 1 ohm stable, it needs to be 1 ohm or higher for the load. Always higher or the same as the stable number. Alright, so the end game. So here we have, we're going to make sure the system actually works. We have a 500 amp hour 12 volt battery. We have a 1000 watt 12 volt amp. And we have 4 speakers. We'll say they're all subwoofers, and they're all 4 ohms. This mess of wire all comes back to these two, and they all hook together. So I ran all the positives to one point, all the negatives to one point, and then put them on here. So all 4 negatives go to a screw, all 4 positives go to a screw. This is a single channel monoblock amp, 4 4 ohm subwoofers, 1 1000 watt amp, and 1 500 amp hour 12 volt battery. So how many watts can this battery put out? Well, we could do 12 volt at 500 amps. So we got our IV equals P, or watts and we have V equals IR, which is our Ohm's law. So in this case, what we're going to do is we are going to calculate if the battery can even handle this system in the first place. So what we do is we make sure that 500 amps and 12 volts equals that wattage or is more. So you got 12 times 500. And that gives us 6,000. So this battery can handle 6,000 watts. Over here, we need to make sure that we can draw the right current, the right load for this amp. So what is the load on this amp in amps? So what we have is we have volts and we have watts, but we don't have resistance. So what we're going to do is we're going to use the P equals VI, and that's going to translate to 1,000 equals I times 12. So we need to divide both sides by 12. And what we get is I equals 83.3 amps. So what you want here is a fuse that can handle at least 83.3 amps. So greater than 83.3 amps. Okay, so now we got our fuse figured out. We know what the battery can put out. We're good. We have 6,000 watts to use. We have 1,000 watts going to the amp. This will also tell you, if this is running full bore, how many amps does it take to keep the battery up and charged. So if you're running your engine, you need 83 amps for this battery to never actually use its energy. Next, what do we have for ohm load? Well, our amp has 4 speakers at 4 ohms in parallel. So 1 over 4, 1 over 4, 1 over 4, and 1 over 4. And what that gives us for our total is going to be 1 ohm. So here's the trick question. Well, what if I take that amp down to half ohm? I know it's going to get louder because it'll push more power. But let's see how much power it does if all of these were 2 ohm and this was down to half. So let's see. If we have V equals IR, and what we do is we try 2 different methods. We try 12 volts, a certain number of amps at 1 ohm, and then we try 12 volts, a certain number of amps at half an ohm. So if we do 12 divided by, we'll start over here, 1, we get 12 amps is the current. If we step it down and we do 12 divided by 0.5, what we end up getting is 24 amps is the current. So what we can do is we compare these two. So how much of a difference is that? It's double. Well, if your amplifier, let's say, has 100 amp transistors in it, and you're doubling what this is currently using in this system, you're taking the current amount and you're getting 166.6 amps. Now if your amp gets really, really hot and shuts down or it breaks, that's probably why you're drawing almost 200% of what you're supposed to be drawing. So what happens if I got 4 ohms? Well, at 12 volts at a certain number of amps, we got 4 ohms, so let's say we're running it higher. Now it's 3 amps is the current, which makes it 12 and 3. 12 and 3 means it's 1/4 of the power. So if we're running 83.3, we divide that by 4, we're only going to be running 20.825 amps. And just so it's clear, we're going to do this. 1 ohm equals that much. 4 ohm equals this much. And 0.5 ohm equals this much. So this is why you don't want to overdrive your amps. If it's 1 ohm stable, it's 1 ohm or higher. It doesn't matter if it's 100 ohms, 10 ohms, 45.5 ohms. It's not going to mess with the amp. What you're doing is making sure that this amp doesn't overdrive. The stable or the rating of the ohm load is the most amperage it can handle at that resistance. Or sorry, what I should say is it is the most power it can handle. So when these transistors are set up, it knows what volts are coming in, it knows what amps it's capable of doing, but it doesn't slow itself down unless you put a resistor in front of it. So what you need to do is you need to put the proper resistor in front of it, something that's either pulling 83.3 for a 1 ohm stable 1000 watt amp, or less amps than what it's rated for, which means running the ohm load higher. So in this case, because I don't make 83.3 amp fuses, you would go to the size that's most common, that's higher than that, and you put it right next to the battery. Don't put it next to the amp. The amp has its own shutdown protection. The battery in this giant strip of wire probably isn't going to have its own protection. It's going to turn into a toaster element when it gets really, really hot and melt the carpet, melt the door panels, things like that, all the way up to the amp. So always make sure your fuse is back here and it's on the positive cable. And that's how you calculate all that stuff. So hopefully that clears a few things up. There's always a lot of questions on things that are non-standard, like the ohms not being even numbers, or running 3 subs off the same amp, or I got too many speakers and not enough terminals. This will help you to figure out what you should have, what the fuse size should be, and how the amp is actually running. Thanks, guys.